Assalamualaikum warahmatullahi wabarakatuh. So these are the calculations for the constants. It's the motor torque, motor speed and armature current from simulation. So and these are the simulations for the two sample of simulation result: speed, motor torque and armature current.
Assalamualaikum, my name is SHUKRI binti SHUKRI. So I will represent for the part B, measurement of motor speed when the torque load is 30 Nm, then reduce 20% of the motor speed by variate the armature resistance. So for the speed of motor before is 408.9 rpm and after is 327.12 rpm. And for the terminal voltage, before is 300 volt and after is 242.45 volt. And this is the simulation of a DC machine so that it can run the motor according to the load torque and the motor speed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Danial bin AHMAD NIZAM and my matric number is B08211037 and I'm from 4BERE. So in this slide, I'm going to explain about the calculation that we had for section B, which is in this part, we continue our study by adjusting the terminal voltage instead of resistance. We first set the armature resistance as before, then measure the motor speed with a torque load of 40 Newton meters. Next, we reduce the motor speed by 10% by varying the terminal voltage. So as you can see in the calculation, we have listed out all the um, information that we need, which is for the Newton, for the speed and rotation, and also the speed that we're gonna reduce, and as follow. For the current, we use this formula, which is IA equals to square root of T divided by R and plus Ri. And then we get the answer, which is it's 2.83 ampere. And then we calculate the power, which is, the voltage, which is terminal voltage using this formula, and gain the new one, which is 271.42 voltage, and calculate the new one. We get the 257.27 voltage. So as for the simulation, our simulation of a DC machine help us observe the effects of voltage changes on motor speed and also the performance. The results showed that controlling speed through voltage adjustment is more efficient compared to resistance control, as it minimizes energy loss. As you can see, this is the diagram or the simulation that we gain after we calculate from the previous calculation, and from that answer we put into this simulation in multisim. So that's all for me. Thank you.
My name is ATIQA SYAZANA. I will present about discussion. Discussion is the simulation show that DC series motor slow down as a load tongue increase. Higher tongue also increase armature current. Speed control was tested by adding resistance or lowering voltage. Adding resistance reduced speed by wasted energy as heat, while lowering voltage was more efficient. DC series motor are great for high starting tongue. Voltage control is better speed control method, and the result match the theory. And the conclusion is the simulation show that DC series motor slow down as load tongue increase. It works well for high starting tongue application like electric vehicle. Speed control using resistant wasted energy, while voltage control is more efficient but limited by the power supply. The study confirmed that simulation is accurate for motor performance and efficiency. That's all.